In this video, we'll go back in time and discuss historical ICS incidents. And it's very important to go back and understand exactly what has happened so far, because we learn from history and the tactics, the problems, the vulnerabilities attackers have exploited in the past could be indicators about what can happen next. And many times we see the same mistakes happening when we do our threat modeling and we try to think of potential attacks and what kind of problems we could have and what is the attack surface. Then it's very important to know exactly what has happened so far in order to have a more complete perspective on behalf of the attacker. So starting the first one that we have documented in history of cyber attacks, cyber incidents, has happened in Australia and in Maroochydore in Queensland, and happened around 2000. So in Maroochydore, they had a new wastewater system that's part of critical infrastructure, as we have discussed in the past. Wastewater, again, is the system where, in our kitchen, in our bathrooms, there's water leaving our house, right? This is being treated, and then it's being deposited somewhere else, or there's a process for recycling, depending on the exact system. But it has to be treated, right? When it leaves the house, it's supposed not to be potable, and it goes to the sewage system, and from there again, depending on the exact system, there's a process that takes place. So this wastewater system, as you can imagine, is spread out the city, right? And it has different pumping stations throughout. So in order to communicate with pumping stations, since they are remotely located and you're not, again, geographically in the same location, you have to have some kind of a remote communication. So in this case, there was an RF-based communication, radio frequency. So there was a SCADA system that was communicating through radio frequencies to the control center. So what happened is someday they had problems they did not expect. They could not communicate. The pumps would not work correctly. And not only that, alarms also did not activate. So it seems to be multiple failures stuck together, and that made the authorities suspicious that something very wrong was happening. As a result of this, 200,000 gallons of untreated sewage were released to waterways and local parks. So you can imagine, again, the kind of sewage that comes out of apartments and houses that went directly to rivers untreated. And since it wasn't treated, then, as the slide says here, rivers turned black, nature reserves were destroyed, and also fish and wildlife died. And also it was a terrible smell for weeks, since again, you have sewage in your parks and waterways. So trying to identify what happened, the authorities actually discovered that it was an individual that was using a two-way radio transmitter. So it was an individual that interfered in the SCADA communications. Remember, that's RF-based, right? So in the pumping station, you have an antenna that listens to commands coming from afar, from a distance. So this individual actually intercepted the communication and managed to send his own commands. And the commands were malicious, as already discussed, that the pumps were not operating, and also the alarms were disabled. The individual used a custom two-way radio transmitter and his own laptop to control 150 pumping stations remotely. So with this kind of interference caused the process attack that we discussed. Why did the person do that? So the person was working for the company that installed the control system. The system that was responsible for controlling and monitoring the wastewater system. And then he got into a fight with his boss, and he resigned. And then he tried to offer his services as an inspector to the council, to the government itself, but the council said no, right? And as a retaliation, or maybe as a way to show to the council that someone is needed for inspection, then the individual retaliated. So here the lesson is that that was in a way that was an insider attack, because the individual was not someone was a random person, right? It was someone with deep knowledge of the system, because he had installed the system, And he also had motive, and that's why this is one of the very few cases that there was actually the culprit was discovered. The individual who did the attack was discovered. It's typically very difficult to find out exactly who did a cyber attack, as we'll see later today as well. So that was an insider attack, someone who knew the system. And I'd like to emphasize insider attacks are one of the most difficult to protect against. And they're very difficult because the individuals involved, they both have physical access to the system. So if there's an access control with physical ID cards or identity cards or eye scans or something, they already have that because they belong to the company, or they know how the system works. And they also have deep knowledge of the system to an extent that they can replicate part of it using their own equipment, and then they can use it to infiltrate and do some damage, as we saw in this example. So insider attacks should always be part of a threat model, and insider attacks, they're very difficult to protect against. Sometimes you can make sure a solution would be you can make sure that every time you have two people to do one task, right? There's a double check for critical tasks in your process. Or you can be doing frequent psychological tests on your employees, make sure something is not wrong, or they're not unhappy, or they're not in a mental state that's not suitable for being employed in critical infrastructure. Still, the attack happened from the outside, right? The attack happened when the individual was not employed by either the company that sold the system or the council itself. So in this way, the problem was that the SCADA communication, the RF communication, was not authenticated. There's no authentication. It's not encrypted. So anyone could, with knowledge of the system, could interfere and interject commands as a kind of a man-in-the-middle attack, as we saw here. So what potential solutions, what could be potential solutions here? The SCADA system could have authentication. So when you communicate, you have to have some kind of authentication process. Communication could be encrypted to make sure that nobody can see what is being sent back and forth. And then in the case of jamming, because that's again radio communication, there are anti-jamming mechanisms that can be employed at the software, the hardware level. And this may be adding to the cost of the solution, but it protects against attacks that can happen, as we see in this incident. So this, at the end of each historical incident, I'll be trying to summarize the attacker, because some attacks are different than the others, right? Depending on the motives, on the individuals, whether it's a nation-state attack, it's an individual, like a disgruntled employee attack, as we saw here, or hacktivist, or some cyber criminals, right? And the type of the attack. So here, it was an individual attack, right? Someone with knowledge performed the cyber attack. And the attack, as we have been discussing IT versus OT security, the attack was directly on the OT side because it affected the pumping stations. Some attacks we'll see today have affected the operation technology, but they mostly came to the IT system. So in this case, the attacker was a disgruntled individual, and the attack type was on the operation technology side. The next attack to be discussed has been named Night Dragon by McAfee. And this attack is expected to have started in 2008. Many times, actually most of the times, we don't know exactly when attacks start, right? We start seeing things after a point. Most of the times we see the attack after it has happened, and we don't know exactly when it started, but there may be indication about when this has started. If it's a phishing campaign that took place, you can go back and see the emails, when the first emails went to the employees. But this attack here, the estimation is that it has started in 2008, and what it did, it mostly exfiltrated data from oil and gas companies. So we discussed it here. It was mostly an IT attack because it was information extraction. But we need to discuss it because it affected critical infrastructure. In this case, it mostly targeted oil and gas companies. So the way the attack happened is the attackers tried to compromise the public-facing web servers. So a company like an energy company or an oil and gas company, they would have a website that's accessible to the outside world, right? That company X website. This is who we are. This is our services. This is our commitment to the environment. So there's a website that's accessible to the outside world that promotes or gives information about the company. So if there's connection between this web server, this website, to the company's IT infrastructure, maybe you can log in, right? And the login credentials are within the enterprise network of the company. Then there's a bridge between the two. So if you compromise the public-facing web server, then you can get into the enterprise network, and then from the enterprise network, you can start moving to the control network. But here the attackers actually didn't move to the control. They stayed at the enterprise network. They installed malware and remote access Trojans in order to get as much information as they could from the computers themselves. So that happened with SQL injection or SQL. SQL injection very quickly if you from network security, information security. So if you don't sanitize the inputs, you have a form you complete, says name, last name, address, and when you insert, when you're registering a user, this name, address, and last name, you put my name, Michalis, last name, Maniatakos, and then when you insert this entry to the database, you have a query, or you have a command, and say insert to the database name equals Michalis, last name equals Maniatakos. So that's a command, right? But SQL injection takes, instead of my name, like Michalis, I also append another command. So if the website doesn't sanitize the input, doesn't remove special commands that I may have maliciously added, then I'm able to do queries to the database myself to the input, right? That's SQL injection. So in this case, they managed to do that. They managed to compromise, and then they installed malware. And once they had foothold in the enterprise network, it was much easier to do lateral movement and find other spots to infiltrate and continue the propagation of the malware from there. In parallel, the attackers also launched spear phishing attacks to make sure they kept getting more and more information. They used password stealing tools like keyloggers. When you type your password, the password was exfiltrated, and they managed to get access to computers that belong to executives, and they captured the emails and files. So again, even though this affected oil and gas companies, it never accessed the control network, at least to the best of our knowledge. It mostly stayed with data exfiltration, but this could be step one in a much larger cyber attack, right? You try to get as much information. VPN credentials, for example, have been used in the Ukraine power grid attack. So the more information you have, the more it can aid in the attack that you want to achieve. So something to discuss. These attacks, again, besides the first one that we saw just now, they're very hard to find out who did it, right? And the attribution problem is generally a big problem in the cyberspace, and becomes even bigger in the OT cyberspace, in the operation technology security cyberspace. So identifying who did what and why, it's very difficult. And it's very difficult because there's no physical act to observe, right? If there's some kind of an action in the world, like someone is shooting someone, there's a car crash, or in times of in war times, there's a bomb falling, right? There's a physical act to observe. You know something happened, you see it, so you can start attributing the attack to someone, because you investigate what happened, and you can say that person or that entity performed the attack. But in the cyberspace, it's difficult because it's all digital, and if it's all digital, the attackers can use also digital tools to cover the tracks. They can delete log files, they can delete events, they can make sure they can remove anything they have added, so you won't be able to see who did what, right? And even if you find the code that's there, you don't know who wrote it, right? And so as to attribute the attack to a nation state, or to individual, or to a criminal group, cyber criminal group. There are some things that have been used for attribution, because even though it's difficult, we have to do it, and it's good to start to understand who's attacking whom. So 4 indicators I discussed here. One is tradecraft. Tradecraft is it's kind of the behavior, right? So it is what we have observed. The same group of criminals, or the same nation state, will be using similar behaviors when attacking a system. They may be relying a lot on spear phishing campaigns, for example, or they may be using the same pieces of malware that they have developed and they reuse them as tools to access systems. Because behavior the habits don't change frequently, right? Behavior and the way the attack has evolved is a very good indicator about who's behind the attack. That's one. Second, infrastructure. Many times when you establish a connection to an enterprise network, to a company, through a malware or remote access Trojan, you want to control that access, right? You have a command and control center, as we'll see in the cyber kill chain lecture. And then you have set up an infrastructure for sending the commands. So these structures, these physical and virtual communication structures, are common, and an entity will be using the same structures over and over because, again, this is what they've been using, has been successful for them. So if we see similar infrastructure, we can maybe attribute the same attack to the same entity. Malware itself, the way the code is written, shows programming habits. So the code that the malware uses can also be a good indicator of who's behind an attack. And the last one that also is used heavily is the intent, right? Who has motivation? Who has reasons to attack? Stuxnet, for example, since it was so focused on a country's uranium enrichment plant, then it was clear. The intent was obvious on behalf of other countries to make sure that this uranium enrichment process is not efficient or that doesn't go through as expected. So countries that are in some kind of a geopolitical situation with other countries, they may have intent to carry out certain actions based on the context. In case of the Night Dragon cyber attack, McAfee attributed the attack to China based on some indicators they had. For example, the first one, they identified the individual in a city in China that provided crucial command and control infrastructure to the attackers. Second was that they identified that the data exfiltration activity occurred from mostly Beijing-based IP addresses. And the third indicator was that they saw that the activity of the attackers happened mainly between 9 a.m. to 5 p.m. Beijing time. But of course, these are all indicators, right? And this attribution process that it's imperfect. It may not be the case. It could be someone trying to, blame China for the attack, and it could have been someone else. But this is the official statement coming from McAfee. So Night Dragon, the attacker type, because also of its sophistication, we can conclude was nation state. But again, there's a question mark there. And the attack type is IT, because even though it targeted operational technology, it targeted oil and critical infrastructure companies, oil and gas, it still stayed only in the IT environment and tried to collect as much information as possible. The next incident chronologically is Stuxnet. And Stuxnet we already discussed in the introduction of the class, and we'll see a lot also later. It will be one of the 3 case studies we'll explore in the upcoming lectures. So I'll go briefly through it now, just for completeness of the presentation of the historical incidents. But again, keep in mind that Stuxnet will be discussed in detail in the upcoming lectures. So Stuxnet is very important because it's the first OT-specific malware we have identified. OT-specific means that it did something directly on the process. In this case, it was affecting the centrifuges that were used to produce enriched uranium. So what Stuxnet did is it was malware propagation, but when it found a computer that was connected to specific PLCs, PLCs manufactured by Siemens, then it was doing some other action. So whenever a connection to a Siemens PLC was identified, it changed the PLC programming. And the PLC was responsible for the centrifuge spinning. So it was changing the pattern of spinning in order to cause mechanical damage or actually reduce the lifespan of the centrifuges. So the centrifuges were being had to be replaced sooner than the expected lifespan. So another unique thing about Stuxnet was not only that it was affecting PLC, but it was also hiding the fact from the operator. So remember we discussed there's an HMI, right? So the HMI is a console that tells the operator what's happening in the operational environment. So in this case, while the centrifuges were not spinning properly, they were spinning very fast or very slow, alternating between very fast and very slow, the operator wouldn't see that, like as they were seeing the measurements coming from the frequency of the centrifuges spinning, they would see normal operation. So Stuxnet was also very advanced because it was also affecting the HMI, and the operator wouldn't have visibility over what's happening in the actual control process. So the Stuxnet attack was so sophisticated that the attribution, it had to be a nation state behind, right? It was OT-specific malware. The way it was being loaded to the computers, it was navigating through, it was changing the frequency, it was affecting PLC programming. It had to point to a nation state. And the attack type was operational technology attack because it was directly affecting the control environment. It was affecting the spinning of centrifuges. So it was clearly an OT attack.